Zero and negative exponents. Read the problem below, then explore simplifying expressions with exponents equal to 0. Simplify 5 to the 0. You can write it another way. It doesn't make sense to ask yourself, what is 0 5s multiplied together? You'll need to approach this problem another way. So far, you have worked with powers where the exponents are counting numbers, 1, 2, 3, and so on. The rules for working with powers are the same when the exponent is 0. You have seen that when you multiply powers with bases that are the same, you add the exponents. Remember, that was called the power rule. No, it wasn't. It was called the product rule. My bad. Okay, it was called the product rule. This is the one where when we multiply 5 to the 0 times 5 to the 4th, we keep the 5, add the exponents to get 5 to the 4th. You can simplify, you can apply the identity property of multiplication. Now, you guys should remember the identity property. You know that 1 times any expression is equivalent to that expression by the identity property of multiplication. 1 times 5 to the 4th is equal to 5 to the 4th because 1 times 5 to the 4th is 5 to the 4th. And 5 to the 0 times 5 to the 4th is equal to 5 to the 4th. 5 to the 0 must therefore be equal to 1. Now, they're calling that an explanation. I don't really feel like they explained anything to you. Think about it this way. If you've got 5 to the 0, that would mean the factor of 5 0 times, right? Now, there's a difference between having nothing and having something. What number is implied? 1. We imply a 1 when we're multiplying because 0 cancels everything out, so we imply a 1. So when you're looking at 5 to the 0, think of it like 1 times 5 to the 0, 1 times 0 factors of 5. So 1 times nothing is just 1. That's why 5 to the 0 is 1. There's no factors for you to multiply by that implied 1. So your answer is just 1. Connect it. Now you will explore the concept from the previous page further. Simplify 5 to the 0. 1 times no 5s would just be 1. So 5 to the 0 is 1. 12 to the 0, 12 is the base, and any base with a 0 exponent is 1. Now on this one, they want an example that would equal 0. You could have made up anything. I'm going to use x to the 0 because any base with an exponent of 0 is 1. Negative 7 to the 0, everything inside the parentheses to the 0 exponent equals 1. I do want to talk to you about negatives. Negative 7 to the 0, we just said equals 1 because everything inside the parentheses to the 0 power. Negative 7 to the 0 is negative 1. The reason why is because this negative is not attached to the 7. Okay, it's not grouped together, it's not attached to it. It would be the same as saying negative 1 times 7 to the 0. And of course 7 to the 0 is 1, so you would have had negative 1 times 1, and your answer would have been negative 1. You have to be really careful with the negative coefficients. If it is not inside of parentheses, you're going to end up with a negative 1 instead of a positive 1. So be really careful with that. In general, for a power where the exponent is 0, this is your rule, n to the 0 equals 1. As long as the base is not 0. Rules for products of powers also apply when the exponent is a negative integer. Now they're going to talk about negative exponents. Number 16, complete this equation. 6 to the 5th times 6 to the 5th. This is a product rule. You are keeping the base, that would be 6. You are adding the exponents, 5 plus negative 5, which makes 0, and 6 to the 0 is 1. Number 17. You already know that a number times its reciprocal equals 1. For example, 3 times 1/3 is equal to 3 over 3, which is equal to 1. Complete the equation. 6 to the 5th times 1 over 6 to the 5th. My advice when you're dealing with a whole number and a fraction is to make the whole number a fraction as well, so that you can multiply straight across. 6 to the 5th times 1 is 6 to the 5th. 1 times 6 to the 5th is 6 to the 5th. Now this is a quotient rule where you would keep the base and you would subtract those exponents, which would end up giving you 6 to the 0, which would again give you 1. Now what they was going for was for you to notice if I have 5 factors of 6 and I divide that by 5 factors of 6, they are all going to cancel, leaving me with just 1. Number 18. Since 6 to the 5th times 6 to the negative 5th equals, we did that one here, 1, and 6 to the 5th times 1 over 6 to the 5th is equal to 1, we did that one in number 17, then 6 to the negative 5th must equal 1 over 6 to the positive 5. Number 19. Complete these examples. 10 to the negative 6, because we talked about negative exponents in the video the other night. When you have a negative exponent, make the base a fraction, 10 to the negative 6 over 1. Flip the reciprocal of just that base, 1 over 10, make the exponent positive. When an exponent moves across the fraction, it becomes its opposite. If it's in the numerator and it's negative, when you move it to the denominator, it becomes positive. If it's in the denominator and it's negative and you move it to the numerator, it becomes positive. Anytime an exponent crosses the fraction line, it changes to its opposite. Negative 34 to the negative 7. Now, this problem you need to pay special attention to because everybody likes to get rid of the negative 7 exponent, but then they go ahead and they throw out the negative coefficient. We're not changing the negative coefficient. Okay, negative 34 is negative 34 no matter what. We're going to make it a fraction. I want to make my negative 7 exponent positive, so I'll flip the reciprocal of that fraction. And I'll give it a positive exponent. Notice 34 is still negative in my answer. Okay, negative numbers are okay. Negative exponents are not okay. On the last one, they want you to work backwards. I've got 142 to the 13th. Let's write this without a fraction. We're going to flip the reciprocal. It's going to make it 142 to the negative 13. And then number 20 gives you the rule. In general, for a power where the exponent is negative, n to the negative a becomes 1 over n to the positive a as long as the base is not 0. We've got 2 examples at the bottom of the page. I'm going to give you 4 minutes to do those 2 questions. Use what you just learned to solve these problems. Write your answers using positive exponents where appropriate. Show your work on a separate sheet of paper. You do not need a separate sheet of paper. 455 0 times is just 1. Simplify 19 to the negative 4. That's a negative exponent. Make it a fraction. Flip the reciprocal. Make the exponent positive. That is your answer. Number 23. Simplify 3 squared times 4 squared to the 5th. There's 2 different correct ways to do this. The first thing I notice when I look at the problem is that there is a group. Well, I would love to do things inside of that group first, but the next thing I notice is that my bases are not the same. That's a little bit of a problem. What I'm going to do the first time I do this is distribute the 5. I'm distributing because my bases are not the same. Not sure what else to do. So 3 squared to the 5th times 4 squared to the 5th gives me 3 to the 2 times 5 is 10. 4 to the 2 times 5 is 10. Now what you should notice is that I do not have like bases and they cannot be combined. But I do have like exponents, so those could be combined. I'm going to pull those 10s off, put my bases in parentheses with an exponent of 10. And then 3 times 4 makes 12. 10, not 12, sorry. So that would be simplified form, 12 to the 10th power. Now there was another correct way to do this. When I looked at the parentheses and saw 3 squared times 4 squared, I noticed right away that the bases were not the same. If you looked a little bit harder, you would have noticed the exponents were the same, and you could have pulled those off. So 3 squared times 4 squared to the 5th, pull the 2 exponents off, sit them on the outside, multiply them by the already existing exponent, get rid of these, and you have 3 times 4 to the 5 times 2. 3 times 4 is 12. 5 times 2 is 10. Same answer. 2 different correct methods. Number 24. Simplify 9 to the negative 8 times 1 over 9 to the 3rd. Write your answer with a positive exponent. There is 2 correct ways to do this one as well. I've got 9 to the negative 8 times 1 over 9 to the 3rd. If I want to multiply straight across and make it one fraction before I do anything else, I can do that. Take 9 to the negative 8, put it over a 1, multiply straight across. 9 to the negative 8 times 1 is 9 to the negative 8. 1 times 9 to the 3rd is 9 to the 3rd. Now I have like bases being divided. I can keep the base, subtract the exponents, negative 8 minus 3, which gives me 9 to the negative 11. I cannot leave a negative exponent, so I'm going to make it a fraction. I could have also left it as a fraction. Flip the reciprocal, and the answer is 9 to the positive 11. The second way to do this would have been to have dealt with the negative exponent at the beginning. 9 to the negative 8 times 1 over 9 to the 3rd. I could have made this a fraction and took the reciprocal of that, which would have gave me 1 over 9 to the positive 8 times 1 over 9 to the 3rd. Then I could have multiplied straight across. 1 times 1 is 1. 9 to the 8th times 9 to the 3rd. Keep the base, add the exponents, 8 plus 3, and I would have got 1 over 9 to the 11th. Same answer, 2 different correct ways to do it. When you simplify this, I've got 45 to the negative 3 over 45 to the positive 3. I'm going to move the negative 3 down. Gives me 1 over 45 to the 3rd times 45 to the 3rd, which makes 1 over 45 to the 6th. Isaac chose A. He divided the exponents, which was incorrect. He should have subtracted and then flipped the reciprocal.